The concept of variable scope changes slightly when we start to define inner functions. Because in this case the variable x is a local variable to the function outer function, and the variable y is a local variable to the inner function. However, when you nest functions, the inner function has access to the enclosing scope, which means in this case the inner function has access to the variable x. And we've called the inner function inside of the outer function. So now when we call the outer function, the inner function is created and called as well. By returning the inner function in the outer function's return statement, we effectively return the return statement of the inner function when calling the outer function. A tuple has been returned. So when we called the outer function, since the inner function is defined within the outer function, it built the inner function. And a snapshot of its enclosing scope state is taken by the inner function, which means it remembers what the value of the variable is when we call the outer function. In this case, our outer function, PowerGen, every time it's called, it creates the function exponent up. We need to return the inner function in order to access the inner function's return statement. Now, if we define a variable as the function call of the outer function PowerGen with a number, the inner function will remember the state of PowerGen, or in other words, it will remember that we passed 2 into PowerGen, and we can call the inner function with different arguments for the num parameter. Squared of 3 passes 3 in as the num argument, because squared is a variable that is defined as the outer function with the power parameter equal to 2. And we can pass different numbers for the num argument, because the power argument is remembered by the squared variable. This is a case where we've created an instance of closure. Closure is what allows us to call squared with different inputs. Squared remembers the state of the enclosing scope or the argument we pass for power. Closure allows us to call an inner function because it remembers the state of the enclosing scope, in other words, the variable power. However, we can't call the inner function explicitly. It has to be paired to the variable that we use to initially define our function call.